All right, well, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? You guys enjoy your no home play day? Let's go. So warm up number 63 is on the screen, and it reads graph. Number one, graph f of x equals 1 over x. Number two, graph f of x equals x squared. Then transform using g of x equals f of x plus 4 in parentheses, close parentheses, plus 2, all of that over 3. Number 3, it says rewrite each expression. Part A, 3a, reads a with an exponent of -2. Part B reads 5 with an exponent of 0. Part C reads, in parentheses, 1 over x, close parentheses, with a negative exponent outside of the parentheses. Number 4, it says, if x to the third times x to the fifth equals x to the 3 plus 5, which is x to the eighth, then rewrite 2 to the exponent of x plus 5. And number 5, it says graph the circle x squared plus y squared minus 8x minus 4y minus 16 equal to 0. So by now you guys should be able to do numbers 1 and number 2. It's basically what we've been doing for the past month almost. And number 5 is a refreshing of what we did with circles. And numbers 3 and 4 is basically just rules of exponents. Let's see how much you guys remember of rules of exponents, okay? But I'll go over those in a little bit. So I'll give you guys a couple more minutes and then I'll go over this really quick. Copy and go. All right, here we go. So for the sake of time, since we have a bunch of stuff to cover, I'm going to go over the warm-up right quick to see how you guys did with that. Here it is. Number 1 says graph. So I'm going to graph that. Let me get this set up. Get my little coordinate plane right here for number 1. And for number 2, I'm going to get my coordinate plane up here to graph number 2. All right, so let's see. For number 1, your graph for f of x equals 1 over x should look something like this. And hopefully you use the table, yes? To plot those points and graph, yes? Yes, Mr. Q. All right, good. Number 2, it says graph f of x equals x squared, so that's a parabola. It should look something like this. However, they give us a transformation, which is this one. But doesn't it look kind of weird? Yeah, because it has f of parentheses x plus 4 plus 2 on top of the 3. However, when we got to these, I showed you how to rewrite these. So here, let me show you how to rewrite it again. G of x equals the 3, the denominator, which is 3, together with a coefficient here, the invisible coefficient of 1, I can extract those, make it a 1 fraction of 1/3. So if I extract that, what do I have left? I have f of x plus 4 plus 2. And now that looks a little bit more doable. All right. So I'm gonna close this session, especially those of you that are late. You barely made it on time. Make sure you stay here on time, because by this, like I said, this last section of the school year is going to go pretty fast, and I'm going to only give that 5-minute grace for you guys to get here. After that, I'm going to lock the session. You can go watch the video on your own, because I have a lot to cover, guys. So here we go. Let's graph this. According to what we see here, we have the 4 is our h, our 2 is our k. So the 4, since it's a positive 4, it's going to the left, and the 2 is going up. So my new vertex is at -4, 2. So instead of being here at 0, 0, I go -4, 2, which is up here. However, this 1/3 corresponds to the parameter a. So if it's a whole number, it usually stretches it. But since this is a fraction, it's going to compress it. So this parabola compresses to look something like this. It's a itty bitty parabola like that. So we move that and we move it over here. There it is. Now it's transformed. All right, let's go to 3a. 3a, let's see, some of you remembered, hopefully. We have a to the negative 2 power. When you guys were with me, hopefully you guys remember, and those of you that are not, so that were not, here it goes again. Whenever you have a negative exponent, I asked for you guys to make a fraction bar. That negative exponent goes to the denominator. This expression goes to the denominator, a, and instead of writing negative 2 as an exponent, I make it a positive exponent. And all I write in the numerator is a number 1. So 1 over a to the second. Okay, part B, 5 to the 0 power. Whenever you have any number to the 0 power, the answer will always be 1. Anything to the 0 power is 1. Part C, whenever you have a negative exponent like this one, and you have a fraction inside of the parentheses, you do the reciprocal of this. So you flip it, x over 1. Distribute the exponent, but it's a positive exponent now. There it is. So if we simplify this, this is x to the 4th power. All right. Let's go to part 4. Part 4 reads x to the 3rd times x to the 5th equals x to the 3 plus 5, which is x to the 8th. And then they're asking us to write 2x to the exponent of x plus 5. So if you notice, the 2 to the exponent of x plus 5, doesn't it look like this one? Yes. So if it looks like that one, let me go backwards. What would it look like before it became 2 to the exponent of x plus 5? Oh, well, if x to the exponent of 3 plus 5 became x to the 3rd times x to the 5th, that means this one becomes 2 to the x exponent times 2 to the 5th exponent. All right, so let me simplify that. 2 to the 5th, we can do that. 2 times 2 times 2 times 2 times 2, which is 32, times what is left over here, 2 to the x. There it is. All right, and last but not least, let's go over our circle. Yay, our favorite. Here we go. So first things first, we need to eliminate the constant. What is our constant? 16, negative 16, so we add 16 to each side. And then we rewrite this side by combining like terms. So we have in parentheses x squared minus 8x empty space plus, what else do we have? Y squared minus 4y. My goodness, I keep moving my slide to one side. Y squared minus 4y empty space, and all that equal to 16. All right, so complete the square. How do we complete the square here? Oh, that's negative 8 over 2 squared. We do that to both sides, negative 8 over 2 squared. And here, negative 4 over 2 squared. Add negative 4 over 2 squared to each side. All right, so let me simplify this. X squared minus 8x plus 16 plus y squared minus 4y plus 4. All that equal to 16 plus 16 plus 4. And I can simplify this a little bit more, so that's 36. And I bring this down, x squared minus 8x plus 16 plus y squared minus 4y plus 4. All right. Next, am I done? Can I graph my circle from there? No, Mr. Q, we need it in standard form. So what do? Oh, I remember. Square root of the first, square root of the last, x, 4, sine of the middle, squared, plus square root of the first, square root of the last, y, 2, sine of the middle, squared equals to 36. Now we can get our center. The center is h and k. H is here, k is here, so this is 4, 2. what else do I need? I need a radius. What's my radius? Well, 36, take the square root of 36, that's 6. Let's graph that. All right, so 4, 2, 4, 2, so it's about right there. And then we plot a point 6 steps from the center in all 4 directions. 6 steps up, 6 steps to the left, 6 steps down, and 6 to the right. And our circle looks something like this. Bam, let's go. Is it coming back? Yes? Yes, Mr. Q. These are my favorite. Yeah, I know. All right. All right, let's move on. And once again, we have a lot packed today. So please, if you're watching Kardashians or SpongeBob, whatever it is you watch, stop it. If you're gaming or doing social media, turn that off and stay focused, please. Today's going to go super fast, and it's got a lot of stuff in it. So focus. Here we go. Our agenda for today, warm-up number 63, we just finished. We are moving on to rational functions, and our home plate for tonight, pages 394, 395, odds only. So again, warm-up number 63, rational functions, home plate for tonight, pages 394, 395, odds only. Asynchronous code. L8D3N. 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 Previous home plate, we had none. It was some time off. You guys enjoyed the time off, yeah? Yes, Mr. Q, thank you. You're welcome. All right. Once again, your home plate for tonight, pages 394, 395, odds, and we're going to be graphing today, okay? So don't worry about what the instructions on the page for the home plate say. You're going to do what we do today in class with those problems. I'm going to repeat that again. Today, what we do in class, that's what you're going to do with your home plate, okay? Yes, Mr. Q. All right. All right, here we go. I can solve and graph rational functions. I can solve and graph rational functions. Our objective for today, I can solve and graph rational functions. Like I said, today we're only going to focus on graphing. And what are we graphing? Rational functions, our new concept for today. So in your Fourier model, you're going to write rational functions. Here we go. What are rational functions? Well, rational functions are an equation that contains one or more rational expressions. An equation that contains one or more rational expressions. Now, for those of you that forgot, a rational expression is anything that can be written as a fraction. Any expression that can be written as a fraction is a rational expression. So, definition says an equation that contains one or more rational expressions. Example given, 6 over g plus 4 equal to 2. The other example, 2x minus 14 over x squared minus 15x, and all that equal to 1. Another example, 2x plus 6 over x squared plus 5x plus 6 equal to 1 over x plus 3. Now, as you're writing those down, let me reiterate the definition. It says rational functions are equations that contain one or more rational expressions. So notice it starts with an equation. Let's see, do we have equations here? Equation, 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 yes. Do they contain one or more rational expressions or one or more fractions? Let's see, does this one have a fraction? Yes, it's right there. Does this one have a fraction? Yes, right here. Does this one have a fraction? Yeah, it has 2 of them because the definition says one or more rational expressions. Okay. So now that we know what they are according to the definition, let me show you non-examples. Copy these. 6 over g plus 4, x squared plus 3x plus 2, and negative 3 plus x equals 10. So as you're copying those, start thinking, why are these not rational functions? Why are these not rational functions? Why are these not rational functions? So let's see. Look at the first two non-examples. This one, 6 over g plus 4 and x squared plus 3x plus 2. Why are those not rational functions? What do you think, Angie? Why are these not rational functions, these two?
It's not an equation.
They're not equations. That is correct. These are only expressions. Okay. With that said, look at this one. Negative 3 plus x equals 10. Why is this not a rational function? What do you think, Addie? Why is this one not a rational function?
It doesn't have any rational expressions in it.
It doesn't have any rational expressions. Thank you. So I'm going to give you the hashtags for today. Like I said, I got to keep moving. We need to get through this session, and we have a lot of stuff to do. So our hashtags, write this down. It has to be an equation, so hashtag equation. What else? Hashtag at least one rational expression. Yes. So those are the critical attributes of rational functions. Are we good as to what rational functions look like? Yes? Yes, Mr. Q. All right. Let's move on. So copy these steps, please. As we move closer to the end of the year, we're going to get closer to multi-step stuff. So I'm going to give you steps so that you have at least a guide as to what to do, and so that you don't get lost. So write this down, steps. Number 1, identify the vertical and horizontal asymptotes. Let me read it again now with parentheses. It reads, identify the vertical, parentheses x, close parentheses, and horizontal, parentheses y, close parentheses, asymptotes. Number 2, build an input-output table. And number 3, graph the function. All right. Once again, number 1, identify the vertical and horizontal asymptotes. Number 2, build an input-output table. And number 3, graph the function. All right. So, since we're moving on to a new function, I need to take a step back and take you back to our general rule of transformations. Let's see if you remember. Our general rule for transformations is g of x equals a times f of 1 over bx minus h, close parentheses, plus k. Now, if you remember or recall, we said that k moves the function in which direction? Show me with your hands. Yeah, some of you are pointing up, some of you are pointing down. Yeah, so this moves it either up or down. Up, positive, down, negative. H moves our functions which direction? Show me with your hands. Yes, I see you guys motioning to the side. Yeah, it goes either to the left or to the right. To the right if this number is positive, to the left if this number is negative, which makes this a positive whatever number, okay? And then A stretches if it's a whole number, it stretches the function. Let's say it's a parabola, it stretches the function vertically, or it compresses it vertically. Vertically. Remember that? Yes. So that means that B, it stretches it or compresses it horizontally. If it was a parabola, it would stretch it in that direction like so, or compress it horizontally like so. Okay? We good so far? Yes? Yes, Mr. Q, I remember. All right, good. And plus, I'm pretty sure you guys have a poster frame of this on your bedroom or something, right? In the garage. No? Sorry, I see you. I see you, Mia. All right. However, that was like kiddie stuff, right? We got this, yeah? So let's move on for today. Write this down. Let's go. So write this down. We got g of x equals a times f of parentheses. Inside of parentheses, we have 1 on the numerator, and then you get your fraction bar. Then on the denominator, we have 1 over b, parentheses x minus h, close parentheses. And then the big parentheses, and outside we have plus k. Now, guys, let me introduce you to rational functions rule. Students, rule. However, I'm pretty sure even though it looks kind of funky, you can identify the parameters, yes? Can you identify the parameters? Yes. So what does K do? Moves it up and down. How about H? Side to side. How about A? It stretches it or compresses it vertically. How about B? Stretches it or compresses it horizontally. Okay? All right, so far up to right there, the only thing that changed is that they added that 1 on the numerator inside of the parentheses, okay? However, look up to the screen. Today, H and K are going to play another role, aside from moving the function with transformations. They're going to play another role. So that means they're going to serve another purpose. What is that purpose? They're going to be our asymptotes. You're like, oh my goodness, what is that, Mr. Q? Well, let me show you. Asymptotes. Asymptotes are, or an asymptote is a line that a graph gets closer to as the absolute value of a variable increases. Let me repeat that again. An asymptote is a line that a graph gets closer to as the absolute value of the variable increases. Now, that might sound a little confusing. Let me put it in Mr. Q's word. Here it goes. In other words, it's an invisible line that a graph will get close to, but will never touch. Is that a little bit better? Yeah? Yeah, it's an invisible line that a line will get close to, but it will never touch. So let's see, let's say, oh, I know. Let's say I said it, Jaziel. I'm gonna ask you to get close, and I'm gonna ask you to give me a high five. So then she's gonna get close. She's gonna give me a high five. But since right now we're doing social distance, and I'm a Jedi Master, when she goes to try to give me a high five, there's an invisible force that does not gonna allow Jaziel to give me the high five. She's just gonna feel the force like whoom. So she won't be able to get close. Well, guess what? That's called an asymptote. An invisible force field that we cannot cross. We can get close to, but never cross. Okay? There's 3 types. There's vertical, horizontal, and diagonal. Once again, vertical asymptote in blue, horizontal asymptote in red, diagonal, slant, or oblique in green. We're going to get into that one later because this is probably the most challenging of all of them, the oblique or slant or diagonal. Today, we are going to get into the vertical and horizontal. So, any questions on asymptotes? Does everybody kind of understand what I'm talking about? Yes, Mr. Yu, that it's something invisible, a line that's invisible, and that the graph will never cross. Okay. So, with that said, let me go back to our general form. Ready? Here it goes. Here's our general form again. There it is. And I said today that H and K will be our asymptotes. Well, let's label H in blue. That's going to be our vertical asymptote. So when I give you a function and you see that there's a number there next to the x minus, well, that's going to be our vertical asymptote, or the invisible vertical line that our graph will never touch or get close to or cross. It will get close to, but it won't cross. So if H is our vertical asymptote, what is K, Hayden?
Horizontal?
Bam! Let's go. So label that in red, please. Horizontal asymptote, yes. So H is our vertical, K is our horizontal. I'm going to be using those two colors throughout our graphing today, so make sure you have your colored pens ready. Okay.
Mr. Q,
Mhm.
I have a question.
Yeah.
Are they like reversed? Because like vertical means up and down, right?
Yes.
H was for left and right,
Yes.
but as an asymptote, it's for up and down.
I know it kind of like throws us off, right?
Yeah.
Okay, and I'll cover that right now. I'll clear it up. Yeah. Okay. Y'all with me? Yeah. Okay, so let's go to asymptotes on your paper. Here we go. On the first coordinate plane that you have there ready, I want you to write example 1. And I'm going to leave the general rule over here on the top right. You don't have to rewrite it. I just have it there for reference. And we're going to do example 1 super Q. Write this down. Y equals 1 over x minus 1 plus 2. And once again, students, rational function, students. I'm introducing the formula. There it is. You're like, oh, hi, nice to meet you. What's your Insta? I know, what a trip now these days. Before it was like, hey, can I have your number? And we actually dialed numbers for the phone. Can you believe that? You're like, what? Yeah. Now it's like, hey, what's your Snap, Kit, WhatsApp, or whatever it is you guys have. All right. So here we go. Look up to the screen. We're going to identify our asymptotes given that function. That's why I left this general form over here. Here we go. So I'm going to write first in blue next to it, VA. What does VA stand for? Vertical asymptote. However, look up, I'm going to label it as X equals to. And now it's going to make sense right now when you see it. Watch. So pay attention, Hayden. Here we go. This is going to clarify that doubt, that question that you, and not only you, some other people might have the same question. So look up. So our vertical asymptote, by looking at it, look back and forth. Here's our general rule. Here's our function, general rule function. Does everybody agree that our vertical asymptote is 1? You guys see that? Yes, because we have an X. Yeah, there's the X. We have a minus. Yes, there's a minus. So what's the only thing that's changed? Instead of H, we have 1. So if X is 1, where's X1? X1 is right there. And if I was to graph an invisible line going through that value, let me show you what that's going to look like. An invisible line going through X1. There's that line going through X1. What kind of line is it if it's going up and down? Yes, vertical. That's why it's known as a vertical asymptote. Does that make sense now? You're like, oh yeah, now that it makes sense, Mr. Q. Yes. Okay. Let me move it a little bit more to the left. There it is. Okay. So with that said, I want you to change to red, and I'm going to write HA, and I'm going to write Y equals to. So by looking at our function, show me with your fingers the horizontal asymptote. Yes, I see some of you. Deuces, there it is, 2, yes. Okay, so let's go to Y. Here's a Y-axis, look for 2. And a line has to cross the Y-axis, and it's a horizontal. That means side to side. So we graph that. Yes.
Wouldn't the horizontal asymptote be -2 because with the other one we flipped it from a negative to a positive?
Okay, good observation. Look up to the screen, guys. So your brain right now is getting short-circuited. Okay, so look, this is the way of looking at it. Here's an X. Oh, for my general form, there it is. Yes, it's part of the form. Yes. Here's a minus. Oh, here's a minus. Yes, so it's there. So that means that the 1 is my H. So that's why we wrote it there. Okay, let me continue with the form. Here's a plus. Do I have a plus? Yes, okay. And what do I have left? The 2. Is that k? Yes, that's why we just write 2. You see what I'm saying?
Yeah.
The only time it changes is if I had here that. Because look, x is here. This should be a minus. But right now, if you were to say that our vertical is 1, but this has to be a minus, so that this would be what? -1. That's the only time it changes. Okay? All right. All right. Not bad, not bad. Okay, next. I want you to write example 1q, because we skipped it. So I want you to write f of x equals 1 over x. So I'm taking you back to the OG, the original one. Remember the parent function, f of x equals 1 over x. This is the original one. Okay, but this one also has a vertical asymptote and a horizontal asymptote. So before you give me an answer, look at the general rule, start matching everything, see what it has, what it doesn't have, and let's see, what would be our horizontal asymptote, our vertical asymptote? Let's see, vertical asymptote, Esmeralda, what do you think?
0.
Damn, Esmeralda, let's go. Yeah, that is correct. Why 0? Well, let's see. Here's the x, but it's missing all this, Mr. Q. Yeah, if it's missing all that, then that means it has to be a 0. That is correct. Okay. With that same thought, what is our horizontal asymptote, Anthony?
0.
That is correct. That's also 0. So let's graph our asymptotes. X equals 0. X equals 0 in blue. Here's x. Notice I'm thinking about the x, and it's a vertical, so that means it goes up and down. There it is. And on the same 0, I'm gonna sketch my horizontal asymptote. There it is. All right. So far, so good, yeah? All right, let's move on. Copy this one, example 1 mega q, y equals 1 over 2x minus 3 plus 5. Y equals 2x minus 3 plus 5. Y equals 2x minus 3 plus 5. All right. So here we go. I'm going to write vertical asymptote. X equals horizontal asymptote. Y equals. Now, don't go ahead of me on this one. Look up. Now, if you notice, our horizontal asymptote, the red one, which is K, it's fairly easy to spot, yes, which is what? 5. Okay, so that one's the easy one. However, look up, please. Who notices that our denominator, it's just a tad bit different from the other ones? What do you guys notice that's different? Yeah, I see Mia saying that the 2. Yeah, the coefficient of 2 here for x. Whenever you have a denominator that looks like this, even though it's a minus and it has a number there, if the x has a coefficient, look up, I want you to do this. set that equal to 0 and solve for x. And that's how we're going to find our vertical asymptote. So that means we add 3 to each side. 2x equals 3. Divide by 2. So x equals 1.5. 1.5. All right, let's graph that. X equals 1.5, which is right there. So my vertical is going to be 1.5, and my horizontal is y equals 5, which is right there. Y equals 5, going through that. There it is. Oh. Move this down. There it is. Okay. So let me give you some for you to practice on your own. Here we go. Copy this. So we got example 1A, B, C, and D. Example 1A reads y equals 1 over x minus 3 plus 2. B is y equals 1 over 3x plus 9, and then at the end plus 4. Part C is y equals 1 over x plus 7, and then at the end minus 5. And dy equals 1 over x plus 23, and at the end minus 23. All right, I want you to find me the vertical and horizontal asymptote of all these, and just graph the asymptotes for A, B, and C. I'll give you some time for that. Copy and go. All right. Here we go. So, part A. What'd you get for our vertical and horizontal asymptotes? Octavio. Octavio, going once. Octavio going twice. All right, Octavio, make sure you stay at the end. I need to talk to you. Michael, go.
For VA,
Yes.
3,
And HA.
2.
Bam, let's go. Hands up, you got that. Yes, okay. Part B, what'd you get for VA and HA? Mia.
For HA, I got 4, and for VA, I got -3.
That is correct. Let's go. Hands up, you got that? Yes. And once again, if you didn't get the -3, that means you didn't put this equal to 0 and solve because it has a leading coefficient. So make sure you did that. Part C, what'd you get for our VA and HA? Let's see. About Danny. Danny? Ortega? Okay. Danny, stay behind at the end and talk to you. Victor, go.
For VA, I got 7,
Close.
-7.
Yes, -7. And our
And for
HA,
it's +5, right? +5
uh,
or -5.
-5. The only one that changes, guys, remember, is this one. If it's a positive, then it changes to its opposite. This one, whatever you see, including the sign, that's our HA. And last but not least, just for the sake of time, here we go. Our VA, this one is -23. -23, Michael Jordan. And our HA is also -23. Let me just graph this one for the sake of looking at it. So this is 4, y equals 4. And our VA is -3. Oh, -3 is right there. And that line up and down like so. All right. So with that said, how comfortable you guys here so far with identifying asymptotes from 1 to 5? It's on your screen. Take that quick poll. Yeah, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 4s, 5 4s, 5 4, 5 4s, and so on and so forth. Okay. Okay, good. So yeah, and if you notice, we still haven't graphed, but we already got into the asymptote portion of it. So this is what I want to do next. Look up to the screen. So the portion that I want us to go to in regards to the graphing one, I just want to do a refreshing, this just so that we can apply what we learned so far. You don't have to copy this. I said last week, if we have f of x equals x, that's a straight line. Then we moved on to f of x equals x squared, and that was a parabola. From there, f of x equals x to the third, x to the third. And that one looks like this. And then from there, we moved on to f of x equals x to the fourth, which is kind of like a parabola, but it kind of like stretches like so. There it is. And today we did f of x. Our new one is 1 over x, and all these are parent functions, and the graph that we've been practicing on the warm-ups looks like this. You agree with that? Yes? Yes, Mr. Q. Have I given you practice of all these? Yes. All right. However, look up. What happens when we do this? When we put a negative in front of the function? Well, it reflects about the x-axis or the inverse. How about this one? How about this one? How about this one? And guess what? And it works as well with these. If it reflects, that means this one, imagine a mirror, it's going to reflect, and that means it's going to be over here. And this one reflects, and it's going to be down here. You guys see it? Yeah, kind of. Yes, Mr. Q, we love these. All right, good. Especially you guys that enjoy the graphing, right? All right. So let's graph one completely the way you're going to do your homework today. Yes? Here we go. Example 2. Copy this. Graph the function and identify the domain and range of f of x equals 1 over x. Now, for the sake of time today, we're not going to get to the domain and range in regards to writing the set notation and all that. But I do want us to get through the graphing portion exactly the way I want the homework. So make sure you stay focused throughout this portion because you're going to need it. Now, right now, as I was going back and forth with my technology, I think I pressed stop the recording. I was recording from the beginning of the lesson till earlier. And then all of a sudden I pressed something that it stopped recording. I don't know where the recording went. So I started recording again. So this should be on the lesson. So I'm going to try and put both of them together if I can find them. If not, then I'll probably just upload the last portion, which is the graphing portion, okay? All right, here we go. So it says graph the function and identify the domain and range. But like I said, today we're gonna focus just on the graphing. Now I'm gonna leave the steps down here so that we can have those for the graphing portion of this session, and we have them there to guide us. So let's look at step 1. It says, step 1, identify the vertical and horizontal asymptotes. So whenever they give you a function to graph, the first thing you do is you write VA, which is x equals to, and HA, which is y equals to. We need to identify those and we need to graph those. So Earlier, we said that our VA was what? 0. And our HA was 0. So let's graph that. Our y-intercept of 0 is right there, and that's a horizontal line. So that's a horizontal line in red. There it is. And the same point is for our vertical asymptote in blue. So in blue through x0, and that's going to be in blue. There it is. Okay, now that we have that, step 2, build an input-output table. So I'm going to write x, f of x. So you're like, oh, Mr. Q, now I understand why you gave us this practice on the warm-ups. Hello. Pick up, man. Pick up. Hello. That's why I gave you this practice. Yeah, so like, now check this out, guys. Look up. Now, I actually gave you guys to write down some numbers for the domain, but let me show you why. Look up. Can we use 0? No, because it's one of the asymptotes. We can't use that because it doesn't cross that. But I need 3 numbers from the left side of the vertical asymptote and 3 numbers to the right. That's why we've been using -3, -2, -1. But for the purpose of today, I want us to go and use a fraction, the number right to the left and right to the right of the asymptote. I want us to use a fraction. So here I'm going to use this fraction, which is -1/2. Then I'm going to use 1, and then I'm going to use -2. So I'm going to write -2, -1, and -1/2. Because those are 3 different numbers on the left side of the asymptote. Now, for the purpose of just whatever, I'm going to put 0 so you guys can see why we can't use 0. And I need 3 numbers from the right side of the asymptote. Once again, the very first number is going to be a fraction, and then I'm going to use 1, and I'm going to use 2. So it's going to be 1/2, 1, and 2. All right, so I'm going to use this f of 1/. So if I was to substitute -2 in here, -2, -2, what does that give us? -1/2. Next, if I substitute -1, -1, and -1, so what is 1 over -1? -1. Okay. Now, the one I do want us to do together is this next one, -1/2. Check this out, -1/2. Whenever you end up with a fraction or a decimal on the denominator, which cannot be because of the rule, all you do, check this out, is do the reciprocal of the fraction, and that's going to be your answer, -2, -2. It's the what? The reciprocal. Now let me explain this as to why. Look up. I'm going to do this work over here. This is the same as 1 divided by -1/2. Is that correct? Yes. So if I write the 1 as a fraction, that means it's 1 over 1. So when we have 2 fractions and you're doing division, this becomes 1 over 1 times the reciprocal of this one, -2 over 1. And that's why this became -2. Okay. Next, 0. Can I put 0 here? Yes. But can we have a 0 in the denominator? No, that's why this is undefined. That's why we cannot use that, because it's one of our asymptotes. Next value that I substitute is 1/2. So if I have f of 1/2 equals 1 over 1/2, what does that give us? Show me your fingers. Yeah, 2, the reciprocal. Then 1 over 1 is 1, and 1 over 2 is 1/2. Let's plot that. Here we go. -2, -1/2, -2, -1/2, -1, -1, -1/2, and -2. Next, 1/2, 2, 1/2, 2, 1, 1, and 2 1/2. And there it is. Woo, let's go. So by now with these, you should be at 4s and 5s. So maybe we finish really quick where you're at so far with these. Yeah, 5, 5, 5, 4s, 5, 4s, yeah. But I want to show you one with all the other stuff. So this is the basic stuff which we've done, and we already covered all the steps. But remember, we need to pick 3 numbers from the left and 3 numbers from the right of the vertical asymptote. So that's going to change on this next one. Copy this one. This is our last one. Example 2Q. Y equals 1 over x minus 1 plus 2. Y equals 1 over x minus 1 plus 2. All right. So according to our steps, it says identify the vertical asymptote. Someone give me that. What is the vertical asymptote?
1.
1, thank you. And we need to identify the horizontal asymptote. Someone give me the horizontal asymptote.
2.
2. Okay, so let's plot those. Y equals 2 is right there in red. And x equals 1. X equals 1 is right there, and that's our vertical asymptote. There it is. Okay. So we're done with that. Next step, I didn't get a input output table. So x, f of x. All right. What did we say? We need 3 numbers from the left of the vertical asymptote. Where's my vertical asymptote? Is this one. So we need 3 numbers. So what is a fraction that's to the left of the vertical asymptote of 1? What would be our fraction?
1/2.
Yeah, let's use 1/2, which is right here. So I'm going to write 1/2. Oh, hold on. Let me write it in order. 1/2. What other number? 0. And what other number? -1. So I'm going to write -1, 0, and 1/2. Those 3 numbers are on the left of the asymptote. All right. So who can give me 3 numbers to the right of the asymptote?
2, 3, and 4.
2, 3, and 4. But remember, I want a fraction close to the asymptote. So I'm going to make it 1 and 1/2. I'm going to write it as 1.5, which is here. And then 2 and 3. 2 and 3. All right. So here we go. I'm going to use this. So I'm going to write f of equals 1 over empty minus 1, sorry. Empty minus 1 plus 2. So here we go. Let's do the first one, which is -1. -1. So what is -1 and -1? That's -2. So what is 2 plus -1/2? That's 1.5. The next one, got 1. And my next value is 0. So what is 0 minus 1? -1. So what is 1 over -1? -1 plus 2 is 1. Okay, next value is my fraction, 1/2. So what is 1/2 minus 1? That's -1/2 over 1. So what does this become? -2, right? Yeah, -2, and then plus 2, that gives us 0. Am I going too fast? We good? Yes? Okay. Next one, 1.5. Let me erase this stuff so I can have more space right here. 1.5. Here it goes. 1.5. So take away 1.5 from 1, so then we end up with 1 over 0.5 plus 2. Yeah. So So what is 1 divided by 1.5? 2 plus 2, that is 4. Next one, I'm going to do in blue, which was 2. So it's 1 over 2 minus 1 plus 2. So this is 1 over 1 plus 2, which is 3. And last but not least, the 3. I got 1 over 3 minus 1 plus 2. So this is 3 minus 1 is 2. So that's 1/2 plus 2. So that is 2.5. All right, let's graph that. Sorry if we're going over time, guys. My bad. But we just needed to get through this last example. -1, 1.5. -1, let me break these marks up again. -1, 1.5 is right there. 0, 1, and 1/2, 0. And then this one, 1.5 and 4, which is up here. 2, 3, and 3, 2.5. There it is. Whew. And that was a lot, yeah? But it's doable. All right, let me relaunch this poll really quick, see how comfortable you are now that you saw it with this one that has the transformations. According to the process, once again, we identify the vertical and horizontal asymptotes. We build an input-output table, and then we graph our function. Okay, 5, 5, 5, 5, 5, 5, 4s, and 1, 3, 5, 4, 5, 4s. Yes. So once again, guys, I'm gonna stop right there. Reminder at 1:15, log on to your Canvas, go to the tutoring session if you need to take that partake from last week. If not, if you want to join us for the tutoring session to go over this home plate for today, see you at 2 o'clock, and also go to Canvas in the tutoring session. Have a good one, guys. Enjoy your home play. Peace. Bye.
Have a good day.
Yeah, you too.